Profesorius emeritas Charles Elachi, atvykęs į Ameriką iš mažo kaimelio Libane, įgyvendino vaikystės svajonę tyrinėti kosmosą. Per daugiau nei 40 metų darbo NASOje Elachi vadovavo bene visoms žinomiausiams misijoms – Curiosity į Marsą, kasinį į Saturną, Juno į Jupiterį ir daugybę kitų. O dabar profesorius daugiausiai dėmesio skiria naujai misijai Europa Clipper, kuri Jupiterio palydove Europoje ieškos nežemiškos gyvybės. Su buvusiu NASA Jet Propulsion Lab direktoriumi Elachi pasikalbėjome, kaip kosmoso tyrimus paveikė pandemija, ką mokslininkai daro, kai misija nepavyksta ir ką jis galvoja, kaip pakelia akis į dangų. JPL and Caltech are closed due to the pandemic. How do you conduct your research now?
Yeah, clearly the pandemic had a significant impact on everybody around the world. So for most of lectures and research and so on, which do not involve laboratory, we're doing pretty well. So we do it all on Zoom or on WebEx. So I give lecture to my students or I meet with the researcher. So we were able to adapt reasonably well. The big challenge is when it involved going to a laboratory and building hardware. So the things which are not critical, we just delay them. But for things critical like the assembly of the rover, which is going to Mars now, we made an exception. And we had always few people, not many, but few people going in the lab with safety equipment. And particularly for things like the Mars rover, they had to suit anyway, because we had to protect the rover from any dust or any other activity. So we were able to manage critical activity, to manage them pretty well. And as you know, now the rover is on its way to Mars.
Are there any other missions or robots or hardware that you're constructing at the moment and that you have to make an exception to finish the work?
Yeah, no, we have a couple of Earth orbiting missions that we had to make an exception. So what we do, at JPL, we have about 6,000 people. So the exception was for 200 people. And they are the people who actually have to touch the hardware. But for all the rest of the people, like the system designer and so on, they get online and they can talk with the person who's actually in the chamber and using cameras and using virtual reality. We have been able to do, I would say, with almost 80-90% efficiency. We have been able to do that. We had to delay a few things, but in general, we managed reasonably well.
So it's a good thing that this pandemic happened in the 21st century when we have all this technology that scientists could use. What about...
Well, I'm not sure. I'd say it's a good thing, but I would say it was, the technology really enabled to address that in a significant way. And as you can tell, many of the things are now being done on the internet. So having the internet really made a huge difference. So that's an example where technology really came to help in an unusual situation.
You said you didn't stop any critical work. What about, other important work that's not critical but important? Did the pandemic slow down anything important?
Yeah, to some extent it did slow it down. Because there is no replacement for being in person. But again, by working very carefully and only having the critical people go to the lab, like at Caltech at the university, people who are working with biological specimens, some of these need to be paying attention for them every day. So we establish rules where people are tested ahead of time, about that they are okay. We establish rules that people will stay away about 6 to, or let's say 2 to 3 meters from each other. Masks are required all the time. And every day we have to identify exactly who are the people we have come in contact with. And so far, we're keeping our fingers crossed. So far, that has worked reasonably well. It slowed down things, but it worked reasonably well.
So it's good news regarding, the work. And so I want to go back a little bit to you. For over 40 years, you've been working for NASA, and for 15 years, you were the director of NASA JPL. Do you have your favorite moments or milestones that you passed during the time?
Yeah. No, I mean, working in space exploration is a very exciting thing to do. So I would say every day was a very exciting day because every day we got new data or we got new information. But I would say the most dramatic time is when we have either a landing, like when we landed Spirit, Opportunity, or Curiosity, or like when a spacecraft which reached its target and we are getting it in orbit, like we did with Cassini when it got in orbit. And the reason, I wouldn't say my favorite time, but I say my most exciting time. And the reason is, we work on these missions for like 8 to 10 years. And everything depends on like those few minutes where critical event is happening. Like when Curiosity was landing, everything depended on those 7 minutes, what we call them 7 minutes of terror, because so many events have to happen during those 7 minutes as we are landing. And they all have to happen perfectly. The equipment has to work perfect, the computer, because we cannot joystick it. It's all done autonomously. And if one thing goes wrong, then we lose the whole mission. So it's like losing the whole effort of 8 years. So these are what I would say very dramatic time, and therefore you remember them. Mm-hmm. So I still remember every one of those landings about the tension and the excitement in the mission operation room. And the same thing for Cassini when it went in orbit.
What do scientists do during those moments, those last minutes prior to landing or entering the orbit of a planet? What do you do?
Well, a few minutes before, or even for the few days before, we are biting our nails on doing that. I think the key thing that we feel kind of a little bit peaceful because we feel that we have tried everything possible, tested everything, prepared ourselves for everything. So when you feel you have done everything possible, you have this tension, but then there's kind of calm, internal calm for a while before the actual events start happening. So the key thing is the feeling that you really have done everything. We keep thinking, have we forgot something? And then as a team, we discuss that. So we usually have people that kind of always keep asking. Their job is to keep coming up with crazy idea. Did you think of this? Did you think of that part? Did you think of that part? To make sure that we have thought of everything. And then we do a lot of dry runs. We do simulation as if we are landing. I mean, it's not exactly correct. It's done through software to make sure that we are prepared for those events. But there is always a nervousness that there is a small chance something will go wrong. Mm-hmm.
You mentioned the Curiosity and Cassini missions that were a huge success. Cassini is finished now, and Curiosity is still working on Mars, exploring Martian Earth. What about, has anything bad happened during those 5 minutes of horror? In your...
Yeah, I mean, everyone's, that, so nobody is perfect. So in the late 90s, we did have a mission which failed as it was entering, the atmosphere of Mars. And as you know, there have been a couple of other attempts, in Europe and in Russia, which have led to failure. But usually we take that as something to learn from. Of course, you feel disappointed. I mean, no question about that. But very quickly, we became in the philosophy that when something goes wrong, okay, we'll go for 24 hours and feel bad, but then we quickly have to come back and see what actually happened, what was the problem happened, and make sure they don't happen again. It's in like everything you do in exploration. Always there are issues and there are problems because that's what exploration is about. You are doing something for the first time, so you cannot predict ahead of time and correct for everything ahead of time. So every explorer, not only in space, but in every exploration, there have been setbacks. And the key thing, I mean, the good explorers are the ones who learn from those setbacks and they'll go and try again. So in everything in life, I would always recommend when you have a setback, don't give up. Just go and learn from it and keep on moving.
That's very nice. But there's a team of scientists, engineers who are humans with human emotions, who have been working with a mission, as you mentioned, for decades maybe, or maybe even a couple of decades, and then something bad happens. How would you, as a leader, motivate your team, inspire them? What would be your first words after an event like this?
Yeah. I think a key thing to do is to prepare people ahead of time. So ahead of time, we do talk what we will do if something fails, just to prepare people a little bit that there is a possibility of failure. So again, what to inspire people, I keep emphasizing to them and give examples of explorers in the past that we kind of adore now. And that gives them example of things where things have failed. So for instance, for example, everybody thinks that Magellan was the first person who went around the Earth or sailed around the Earth. And I keep reminding them that Magellan, did start that mission, but he died in the Philippines, before he completed his adventure. And look, now he is a person who's credited with doing that because he's the person who started working on it. So I usually tell people that, failure is part of our business and people will remember that we tried almost as much as if we have succeeded. People will say in the future, looking back, that, look, this team at JPL actually really opened the doors and they tried to do this thing and they had setback. And people will judge us on how well we recuperate from that. And no question, people will cry, they will feel bad, and that's normal. That's normal. But just to keep telling people that as explorers, people will remember us for trying on doing these things.
Personally, one of the most interesting topics regarding space exploration is the search for extraterrestrial life. And do you think, I'm not asking if you believe, but do you think there's life beyond Earth?
Yeah, no, I do. I do think that there is very possible that there is life, beyond Earth, because there is nothing particularly unique of our planet. I mean, when you look at the sky, particularly with big telescopes, you find that, literally there are millions, if not billions of galaxies, and each galaxy has billions of stars around it. And now we are finding, as over the last 20 years, that almost every star we look at, there are planets around them. Now, some of these planets are more like a Jupiter, where it's maybe too cold, or like Venus, which is very hot. But there are many, many planets which are in an environment which are very similar to our planet. That means the temperature is reasonably, allows liquid water on them. So when you think that there are billions of those stars and those planets, and the laws of chemistry and physics are the same across the universe, I just have to believe that there are a fair number of them where it led to some life, maybe not exactly like our life. Maybe the DNA is different chorality on it, or maybe it's based on something a little different than carbon. But I do believe that it's very, very likely that there is life around the universe. I don't think any of it has visited us yet, so I don't believe that actually other life has come to Earth because of the huge distances that we're talking about. Literally many, many hundreds and thousands of light years. But I think life does exist, in many places across the universe.
So bad news for the UFO fans.
Yeah, well, it's good. It's good to have, a little bit of science fictions. We do rely, one, they make very good movies, but also we do rely on extending our imagination. So my reaction to the people who think of UFOs or have movies about UFOs, that it's good to be thinking outside of the box. because that could lead us to new things.
We search for signs of life, of extraterrestrial life in the solar system, in Mars, in the icy moons of Jupiter and Saturn, and even the atmosphere of Venus. How come A, Mars, B, icy moons of the gas giants, and C, the atmosphere of Venus could be capable of hosting life as we know it?
Yeah, no, I think we are fine. I mean, and that's one of our key goals in space exploration, is to really look, are there any location in our solar system which are amenable, for life, or that life could have evolved in them? And as you indicate, I mean, Mars, the reason we think Mars is a possible target is because we see on the surface of Mars indication of rivers which occurred and water flowing on the surface, which we believe occurred many hundreds of million years ago or billions of years ago. And the geology is very similar to our planet. I mean, when you land on Mars, I mean, with the rovers and so on, you think you are somewhere landing in the Sahara Desert or dry areas, but we do see signatures of water flowing in the past. So the key question is, when that water was flowing on the surface, could have that led to life like what happened here on Earth? In the case of Saturn and Jupiter, we see satellites, of Jupiter and satellites of Saturn, which are made completely of ice, water ice, like what we have in our drink. So we believe that there might be, as you go down deeper below the surface, there are liquid ocean. We can determine that based on the fracture on the surface and the flow, of the ice, as well as from the gravity field. So a key question is, could there be life in there like there is at the bottom of the ocean? And recently, I mean, there was detection of chemicals in the atmosphere of Venus. And on Venus, the surface is very hot, but as you move up in the atmosphere, it gets cooler and cooler, and there is a region of the atmosphere where the temperature is similar to Earth. So the question is, could there be some kind of life which have evolved there? It might not be like you and I, but it could be some kind of bacteria or a different, kind of life which has not evolved as much as all of us has evolved. So I think there are a number of places in our solar system that life could have evolved certain level, and that's the kind of thing that we're exploring.
You are working on a mission called Europa Clipper. It will go to the moon of Jupiter called Europa and search for the signs of life. Can you tell me more about the mission and why Europa is interesting to the scientists?
Yeah, when we flew past mission like Voyager and we took picture of Europa, we were very intrigued that it looks like made of ice, but there are fractures all around the surface, of Europa. And it looks like, when you zoom on it, it looks very similar to what we see when we fly from Europe to the US over the north, over the Arctic, where you see these big ice flows, which are moving, slowly, but moving over time. And Europa looks almost exactly the same. So based on that, data and the data from, Galileo, which was orbiting, Jupiter, making measurement of the gravity field and the magnetic field, we are pretty convinced that just below the surface there is an ocean, and that ice is floating over it. And the ocean is made of water because the ice is made of water. And the reason that the ocean is, the fact that the ocean is liquid means that it's a favorable temperature, that's somewhere between 0 degrees centigrade and 100 degrees centigrade. So immediately the question then is, if it has environment very similar to our ocean, could have life evolved similar to in our ocean? When you go deep in the ocean, even when you don't have sunlight, you actually see life. So we are now developing a mission. Actually, we are building it, where we will go and put an orbiter around Jupiter, but do a series of flybys of Europa. And we will have a series of instruments which will be able to give us information about the composition of the surface, but also a sounder, a radar sounder, which will allow us to determine how thick the ice is. And the reason that's important is we want to, after this mission, we are thinking of sending a lander which will drill through that ice so we can get to the ocean. So we want to know how thick is the ice and are there areas which are relatively thin, so that will allow us to drill through that part. So that mission is called the Europa Clipper, as you mentioned. Where the target is to launch it in 2024. And if all goes well, it will arrive to Jupiter around 2029. So by the end of this decade, we will be able to start getting much more detailed information about Europa and the oceans and how thick the ice is on Europa.
But the ice crust could be from 15 to 25 kilometers thick. How do you plan to drill it?
Well, we hope we'll find places where it's thinner. You are right. It all depends on how thick it is. If it's many tens of kilometers, then that will be a big issue. But we think, based on our modeling, that there might be places which are more in the few hundred meters to a kilometer, because when you look at the size of the ice flows, that give us an indication of how thick the ice is. If the ice was very, very thick, then it's unlikely that these ice flow will break in small pieces of ice, small meaning few hundred meters to few kilometers on doing that. So the fact that the ice flows that we see are relatively small in the hundreds to few tens of kilometers is an indication, based on our best understanding, that there are areas where the ice thickness might be in the hundreds of meters. And in that case, we should be able to drill through that, or we need some new invention, like the people who are listening, young people listening to your programs, maybe they'll be thinking of some ways of actually drilling through that ice. You know, when I go back, when I was a student, a lot of the things we are doing today seemed impossible. But, you know, as technology evolved and smart people work on it, we always were able to come with solutions to overcome these challenges.
Now, going back to Mars, everybody is talking about humans finally going to Mars. When do you think this will be possible?
I think we have the technology to send a human to Mars. We know how to do it. It's a big challenge, the engineering challenge. And also the challenge is the psychological impact, because you have to have a small group of people in a capsule spending 9 months together and have all the medicine that goes with them. And then you spend 6 to 8 months on the surface of Mars and then 9 months to come back. So it's like going in a capsule on a trip for 2 years, and you have to take all your medicine, how you stay in good relationship with the other people sitting with you. Just imagine, I mean, the pandemic is an example where you are kind of, many people are locked in for many, many months. So it gets somewhat frustrating of doing that. But putting those aside, I think it's possible by the early 30s, in the next 10, 15 years, if there is willingness, you know, to do that, and the funding, which clearly it will be an international endeavor. I think that is possible in the early 30s to send the humans to Mars.
And now to your personality. What do you see or what do you think when you look at the stars?
Well, it is fascinating. I mean, when I remember when we landed Curiosity, it was in the evening in California. So after we landed it, I went outside the Mission Control Center, and I looked up in the sky, and it happened that Mars was in the sky, very bright. And I stood there for like 15 seconds. I said, imagine, we have just landed on that, what looked like a star. We just landed on that thing. So it's amazing. And then when you look at the rest of the stars, what's in the sky, you know, it's amazing when you think, how could there be life on these other stars? Could there be somebody like us standing on one of those planets, looking at us and wondering, you know, if there is life here? So, you know, our world is really amazing when you look at how these galaxies and these stars. It's absolutely amazing.
You became a NASA legend despite the fact that you're from a town in Lebanon. What do you have to say for young people who are maybe watching the show now? How would you motivate them?
Yeah, as you said, I grew up in a small town in Lebanon, but I was always fascinated with science and very curious about everything around me. Like you said, I was looking at the stars and wondering, looking at flowers and wondering why they are of different colors. And I never thought that I would be running JPL, 40 years later. But I followed my curiosity, so I always, my parents encouraged me to always, study, but also encourage my curiosity and always ask questions. And, fortunately, then I went to Europe. I went to France, not too far from you, and did my undergraduate, and I came to the US to do my graduate school. So my message to the young people is follow your curiosity. Not only in space, but some people are curious in music or in cooking or in art or any discipline. I think as long as you follow your curiosity and have fun on what you are doing, I think you will do well. In the case of space, a number of people, Lithuania is part of the European Space Agency, so the Space Agency is doing amazing things. In fact, we are collaborating together with the European Space Agency for a sample return mission as the next step after the rover we have now. So there are opportunities, for young Lithuanian if they are interested in space to do that. But as I said, there are also opportunity across different fields. So just stay curious, stay positive. Don't worry. I mean, I shouldn't say don't worry, but don't be. If you have a setback, just keep trying again and enjoy what you are doing.
That's very beautiful. Thank you, and thank you for your time.
Sure, thank you, Rhoda. Have a good day.
Primenu, kad visą laidą galite rasti Delfi portale. Tai tiek, ačiū, kad žiūrėjote ir likite su Delfi televizija.